All right, I'm going to record this for you guys so you get a test review in before Monday's test. So here we go. All right, we start out with exponential function. Y equals AB to the x power. Okay? Now, when we have a 0 for x, we know what A is right off the bat. A is going to be 4/3. Okay? Because we know 4/3 equals AB to the 0. B to the 0 is 1. So 1 is just 1 times A, so A is 4/3. So then we take the next one down, 4/9. 4/9 equals A, which is 4/3, found that out right up there, times B to the first. So if 4/9 equals, or 4/9 equals 4/3 times B to the first, B to the first is just B. So to solve for B, we multiply both sides by 3/4 to get rid of the 4/3. So then B is alone. The 4's cancel. 3/9 is 1/3. So B is 1/3. So what's our function? Our function is f of x equals 4/3 times 1/3 to the x power. That's our answer. Okay? That's our answers. It says use integers or fractions. We had fractions here. Okay? If you need to, maybe you want to put parentheses around there. Okay? All right. Solve the equation graphically. 4 to the x and 2 to the x. Well, let's just look at that. We'll go y, turn it on. Y equals, clear out what's there. 4 raised to the x, 2 raised to the x. And on your calculators, these will be in different colors. This is an older calculator. But if we go zoom 6, let it graph, it's the basic 10 by 10 window. There's one of the graphs. There's the other graph. Okay, so let's see which is which. Okay, if we go this way a little bit and go down, there's 2 to the x down there. There's 4 to the x up here. So 4 to the x is bigger than 2 to the x. Here we see 4 to the x. Where's 4 to the x less than 2 to the x? Well, if x is bigger than 0, like 1, 4 is bigger than 2, so it's not this one. So it's this one. When it's less than 0, back over here. So if we're at -1, 4 to the x is 0.25, but 2 to the x at -1 is only 0.5. So then 2 to the x would actually be larger when we're less than 0. Okay, moving on. All right, populations of a couple cities here. City A, City B. 90 population, 2011 population. Okay, they're both growing. Okay. Using mid-year data and assuming the growth is exponential, when did the population of City A surpass 600,000 people? So we're not even going to worry about this. Okay, because we're worrying about City A. Okay, if it's exponential, we can just totally use our graphing calculator for this. So you go stat, edit our list, put the two numbers in. Okay, so in 1990 and in 2011, we had populations of, come on, oh, enter, then we go over, of 465, 865, and then 820, 144. Enter. So, and then if we go stat, calc, and we want an exponential function because they say right here it's exponential. So if it's an exponential regression, enter, and then just keep going down and go enter, 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 enter. And that's our regression, okay? So it's a very small number, almost 0 there. And then B is 1.027. So let's graph this once. So I'm going to go do the stat calc exponential regression again, but I'm going to store my frequency equation into y. So I'm going to go vars, y vars, enter, 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 enter. And then I'm going to go y equals, clear out that bottom one. And I'm going to graph this. And then we want 600,000. So we need to change our window because our x's are going to be somewhere. We see that we're at 2011 here for the year. So maybe it's somewhere in between 1990 and 2011. So we're going to go 2020. Just go there. That's fine. And then let's go about 800,000 for our population. If we graph it, hopefully we'll see a function. There it is. Okay, right there. So if we trace, we want to find when it is at 600,000. So we want to see the y value when it's 600,000. All right, to do this the best, we should graph 600,000 here as well. That's 60,000. There's 600,000. Let's graph that. There's a straight line, and we want to find where those two intersect. So second trace, intersect, enter, enter, enter. They intersect over there in 1999. Okay? That's when they intersect. So that's using the graphing calculator to help me find the year. Okay? Could you do it another way? Yep. You can find a b to the x here and do it that way. But I think the graphing calculator is way easier. Okay? All right. Here's another one that the graphing calculator is really nice for. But part A, you should have right off the bat. What's the initial number of bacteria present? Initial number is when t equals 0. Well, 0 times this is 0. And then e to the 0 is 1. And 1 times 500 is 500. So you should always know the number in front of an exponential. That's its initial number. After 2 hours, we just stick a 2 in for t. So we go second quit, 500, e, second ln is e, to the 0.694 times 2. Boom. So 2003 bacteria are present after 2 hours. Okay? So that one's fairly straightforward. A lot easier than this one. But this one you can get. You just have to put a little work into it. All right. Exponential function, initial value of 15, decreasing at a rate of 50% per year. So that's A equals 15, B equals 0.5. Okay? So determine the exponential function that satisfies that. So it's 15 times 0.5 to the t power, where t represents time. Okay? All right. Half-life of a certain radioactive substance is 11 days. So the amount equals the original amount times 1/2, because that's a half-life, of certain time over 11 days is a half-life. Okay? All right. So the amount equals, equals 3.1 grams times 1/2 to the T over 11 power. And that goes there for the function. We want to know there will be less than 1 gram remaining after about how many days. So we put 1 in here, 3.1 times 1/2 to the T over 11 power. Now, we'll divide by 3.1 first. 1 divided by 3.1 equals a long decimal, 0.32258 equals 0.5 to the T over 11 power. Now, because we know how to use logarithms now, we take the log of each side. So the log of 0.32258 equals T over 11 times the log of 0.5. So then multiply each side by 11. So it gets rid of 11 and divide by and then multiply or divide by the log of 5. Divide by the log of 5 because it's T over 11. So it's T times log of 5, so we divide by the log of 5. So on the calculator, you take 11 times the log of the last answer divided by the log of 5, and we get negative 7.73. Uh-oh. I wonder, round to the nearest thousandth. There'll be less than... Ooh, Mr. Bierschbach, did you make a mistake? Let me see what the answer to 6 is. Just to see. Because I don't want to lead you astray. Number 6, 17.995. So I got the right equation in there. I don't know what I did wrong right now. All right. Because this is the right equation. So I divided by 3.1. So let me do this. Let me take the log of 3.1 1 divided by 3.1. 1 divided by 3.1. Okay. And then that's what that is, a negative number. We're going to multiply it by 11. We get a bigger number. We're going to divide that by the log of 0.5. I think I divided by the log of 5. That's 0.5 because it's 1/2. Log of 0.5. That's where Mr. Bierschbach goofed up. The log of 0.5 equals, there we go, 17.955. All right. This one, set this equal to x. 8 to the x equals 64. Okay. 8 to the what equals 64? Well, it's 8 to the second power. So x must equal 2. 8 squared equals 64. That checks. The ln of e to the 2/5 power. Well, ln and e cancel, so that's just 2/5. E to the ln of 15, well, e and ln cancel, so that's just 15. The log of x equals 3. Well, the log is base 10 of x equals 3. So that means this is 10 to the third power, Okay, so x equals 10 to the third or 1,000. Okay, so the exponential equation is x equals 10 to the third. And I wonder if that's the way they want it written. Let me get the answers again. X equals 10 to the third. Yep, that is right. All right. What's the approximate value of the common log of 17? So you go log of 17 on your calculator. Log of 17. And it's 1.23045. Okay? Express as a difference of logarithms. When it's dividing, you subtract the log of 64 minus the log of x. Write this as a single log. This is the ln of x to the fourth, because the 4 goes as a power and the 5 goes as a power, plus ln of z to the fifth, and then you write it as 1. So it's the ln of x to the fourth, z to the fifth. That's writing it as one log. Okay, change of base formula. Log base 9 of 14 is log of 14 divided by the log of 9. Okay, that's what you write in here, log of 14 over log of 9. And then you do the calculation. Log of 14 divided by the log of 9. And it's 1.201. Okay. Find the exact solution algebraically. Okay, we're going to divide by 4 first. 2 to the 1/4 x, because x over 4 is 1/4 x, equals 8. Okay, so 2 to the 1/4 x equals 2 to the third. Once you have the bases the same, you drop the bases. 1/4 x equals 3. And then you multiply by 4. X equals 12. Okay. 1.15 to the x equals 4.9. Take the log of each side. Then that x moves out front. X times the log of 1.15 equals the log of 4.9. Then divide by the log of 1.15. So the log of 4.4 divided by the log of 1.15. 10.601. Okay. All right. Find the amount accumulated after investigating the principal at P for T years at an interest rate R compounded continuous. If it's compound continuously, it's the E. Okay. So you take 29,000 times E to the RT, 0.035 times 11. That's compounded continuously. 29,000 E to the 0.035 times 11. 42,618.82. Okay. Doubling time to invest. Okay. So let's say you have $1. When you double it, it becomes $2. So $2 equals $1. And it's in compounded quarterly. So you're taking it times 1 plus 0.056 divided by 4 to the 4t power, or t times 4 power. Okay? So do the math inside here. 1 plus 0.056 divided by 4 equals 1.014. So it's 2 equals 1.014 to the 4t power, and then you're going to log both sides. Okay, and then the 4t goes out front. So the log of 2 equals 4t log 1.014. And divide by 4 log of 1.014. So the log of 2 divided by 4, and then divide by the log of 1.014. And you get 12.46. And then you just subtract off the 12, and then that's the percentage of a year. If you take it times 12 months, you get the exact number of months, 5.56. So it's 12 years and 6 months. 12 years and 6 months goes in there. Let me check the answer. That's number 18. Zoom on down. 12 years, 6 months. Okay. How many years are required for an investment to double if it's appreciating at a rate of 2% compounded continuously? All right. Doubling. All right, let me erase this. I was just practicing a little bit. Doubling. So it's $2 for every $1. E to the RT 0.02 times the time power. Okay. So a way to get rid of e's really quickly is natural log both sides. So 1 times anything is 1, so I just got rid of the 1, took the natural log of each side. So the ln of 2 equals 0.02 to the times t, and divide by 0.02. So take the ln of 2 divided by 0.02, and you get 34.66, or 657. 34.657 to 3 decimal places. Okay? What's total value after 8 years of initial investment is $1,750 that earns this much compounded quarterly. Okay? 1750 times 1 plus 0.073 divided by 4 to the 4 times 8 years. So 1 plus 0.073 divided by 4 is 1.01825. Raise that to the 32nd power and take that times 1750, and ta-da, 3121.62. E. There we are. Okay, so that's everything that you'll see on your test. That was a fairly quick video, but I think I explained everything fairly well. Hopefully you've got it down good enough where you can handle it. All right. We will see you on Monday, and hopefully you have a good test. Be safe this weekend at formal, and go dogs.